Andy, welcome.
Thanks, great to be here.
Very excited to have you. So, general partner at GV, formerly known as Google Ventures, but now officially GV, right, for the last year.
Yeah, that's right. Ever since the Alphabet changeover.
Okay, very good. All right, so we're going to get into a bunch of things. You have a super interesting portfolio across a bunch of different areas, from 3D printing to Internet of Things, to the reinvention of food and agriculture, to a lot of robotics. So we're going to spend the bulk of the conversation going through those various areas. We'd love to hear your thoughts on where those industries are, what you're excited about, what you're less excited about. But to get started, maybe a few words on your background. You're actually one of the rare VCs with a technical engineering background, which is terrific. Do you want to maybe tell us a little bit about how you started your career and how you got to eventually join GV?
Yeah, sure, happy to. So originally trained as an electrical engineer and computer scientist at MIT, and basically got started in startups while I was still in school. So I started working with a startup called Zipcar while I was actually doing my master's. I don't really recommend doing that, but it was sort of .com era, and everybody around me was dropping out to go to .com startups, so I got tempted. And I built the technology that went in the cars. So if you ever used a Zipcar, the RFID systems and the cellular communications that link up the car electronics to their management platform. And then I just kind of got hooked on the startup thing, and so worked at startups the whole rest of my career until becoming a VC. So I started a company that was commercializing my thesis work, which was in low-power wireless communications. So it's now a standard called Zigbee. A bunch of the routing algorithms for my thesis are the routing algorithms in that standard. We started as a software company. It was called Ember, and through a very strange twist, and this is a standard startup story, I suppose, we became a chip company. So I moved into the hardware side and built the first 802.15.4 chips that were fully integrated. So microprocessor, flash, and RF on one piece of silicon. Sold that company to Silicon Labs. Those chips found their way into all the Nest thermostats, lots of smart metering devices, and so a lot of energy applications, even though that wasn't what we originally built the company for. And so I decided actually to join a customer of mine called Tendril, largely because I got tired of being at the semiconductor layer. It was very far away from end users, and I wanted to be something kind of closer to end-to-end application. So Tendril did energy management for residences. We sold software utilities, and did that for a little while, and then moved out to the Bay Area where I did my last startup, which was called Adura Technologies. We did energy management for commercial buildings, so lighting control systems that were wireless and retrofittable. And when we sold that company is basically when I joined GV. That's about 6 years ago. And since joining, I've been focused on companies that I say intersect the physical world. So I have software companies in my portfolio, but they tend to be companies in things like logistics or manufacturing where there's still kind of a physical world tie. And then the bulk of my portfolio is really things like hardware, agriculture, food, much more sort of real physical products.
Terrific. And maybe spend a couple of minutes on GV. So it's a name that a lot of us have heard, but maybe some specifics around geography, stage, what the firm does in general, and then what you do specifically as well in terms of geo and stage.
Sure. Yeah, so GV is a fairly early stage focused fund. We have a single LP, and that LP's Alphabet. Historically was Google. We are very unusual, I would say, in what you would consider the corporate venture space, in that we don't have a strategic mandate. So we're set up truly as a standalone venture fund. We make all our decisions internally. There's no connection to people inside of Google on our decision-making process. And we're measured only on our financial returns. Today we manage about $3 billion, and we've got about 300 portfolio companies. There are 10 general partners and about 20 total people on the investing team. The other thing that's pretty unusual about us is we decided that we were going to be pretty operating focused as a fund. So there's about 70 people in the fund overall, and most of the non-investors are operating partners. So these are folks who, like designers, recruiters, engineers, and their day job is helping our portfolio companies. And so it's a kind of a somewhat different model than the bulk of VCs out there. Geography-wise, we are United States, Canada, and Europe right now. Eventually may go broader than that, but right now that's the focus. So today we have one GP in London, one in Boston, and then the rest of us are Bay Area of the 10. And from a sector perspective, we're basically anything technology oriented. So we've got a very active life sciences group that's based out of Boston. And then we do all the things that you might expect somebody affiliated with Google or Alphabet to do, consumer, internet, those sorts of things. And then obviously we stray into hard tech with folks like myself.
And sorry if I missed, but you do seed to late stage?
So historically we did seed. Actually, we don't do seed anymore. Basically, as the fund got larger, it became difficult to kind of deploy the dollars writing seed checks. And so today our minimum check is around 5 million. And I would say the bulk of the checks are kind of 5 to 25 million. And basically that's Series A through C. Very occasionally we'll do growth after that, but largely that's another group within Alphabet called Capital G.
And you guys lead rounds, participate in rounds, all of the above?
Yeah, we're fairly flexible, perhaps more flexible than most firms. You know, a lot of rounds we do lead and take a board seat and look very traditional early stage venture, but we are more amenable to partnering with other firms and not taking a lead check. Usually in those cases, obviously, we won't take a board seat, but we're open to all structures.
Great, thank you. All right, so let's jump into it, into those various areas that you focus on. And yeah, I'm interested in, you know, what's hot, what's interesting, what's less interesting, how you think about the space. So maybe let's start with 3D printing. So 3D printing is interesting, right, because it was a space that had offered a lot of promise several years ago. There was this whole concept of consumerization with MakerBot that never quite happened. Meanwhile, there was a lot of action on the enterprise side, industrial side, and it sort of went quiet, and now it's sort of coming back up, including with 2 startups that you happen to be investor in both, Carbon and Desktop Metal. So how do you think about the space? What gets you excited?
Yeah, for sure. So I think at the highest level, the thing that gets me excited is the transition I see happening now for 3D printing to move into mass manufacturing. So 3D printing has been around a really long time, right? There's a couple public companies that have been around for a long time that were primarily being used for prototyping. And then there was a big hype cycle as, you know, some of those things came off patent and people found a way to make those same technologies much smaller, fit on an engineer's desk, potentially in people's homes. And so that was right about the time that I joined GV, and so I got super interested in it. I'd, you know, again, made physical products in almost all my startups, and I got a little bit disillusioned after looking at a whole bunch of companies because I felt, well, you know, these are cool technologies, but they're not going to make the jump into real production, right? Like on the plastic side, for example, there were issues around the parts not having the mechanical properties and material properties that you would get out of traditional techniques like injection molding. And then on the metal side, it was basically very expensive, right? The parts you got were awesome, but the machines were $1 million, and you need highly specialized metal powders to go into them and things like that. So what I started doing was watching the space, trying to find people that could make a technology that could actually jump into real manufacturing, which is what I thought would be really interesting. And the first company I invested in that was doing that is called Carbon. They're on the polymer side. Very technical team, very unusual, but kind of an interesting model for the space where they have, you know, kind of all disciplines under roof, right? So they've got a very large material science team. They also do the software and the hardware all in one space. And if you look at a lot of the legacy companies in 3D printing, they're really mechanical engineering and some software. They're not usually building the materials. And as it turns out, if you really want to crack the puzzle in terms of, or solve the puzzle in terms of getting into manufacturing, you really need the material science piece as well to figure out how to make materials that have the right properties, right? So Carbon has a technology that's a continuous technology. So most 3D printing is kind of layer by layer. Carbon kind of pulls the part directly out of a vat of liquid in a continuous manner, and that gets around some of the material property issues. And it also happens to be a lot faster than the existing processes. And so that combination is something that I think allows it to go into mass manufacturing. And so some of you may have seen they announced a product with Adidas, depends on if you're German or not. It turns out it is Adidas. And it's really the world's first consumer mass manufactured 3D printed product, which is a shoe that's begun shipping now. And so ever since making the carbon investment, I looked around and thought, well, somebody's got to solve the issues on the metal side. Again, it wasn't about functional parts, it was really about cost and ease of use, right? So even metal was kind of limited in prototyping just because the machines are not the kind of thing you can put in an office. They require an industrial facility. The powders are explosive, for example. And so Desktop was a company I came across, started primarily by MIT professors and a VC actually in Boston. And they basically figured out a way to make metal 3D printing. They have actually two different processes, but one allows it to be office safe, and so that's aimed at the prototyping market. It's about a $100,000 machine, so order of magnitude reduction from existing machines, and you can put it in an office. And then there are other technologies, a production technology, and it's about 100 times faster than existing metal 3D printing and uses commodity metal powders. So anyway, very excited about what's happening in terms of 3D printing making the transition to manufacturing.
And so the prototyping market is where most of the action is currently, or some of those emerging, this emerging generation are they in production?
Yeah, so these two companies I invested in are almost entirely aimed at production. So Carbon really doesn't sell these days to the prototyping market. They sell almost exclusively to companies who are looking to mass manufacture products. Desktop's a little different in that their first shipping product is aimed at the prototyping market. And then kind of where most of the development effort is on the production technology.
Are there other parts of the 3D printing market you're excited about?
Yeah, so I think one of the I'll point out a challenge, I guess, maybe to start with, and then that kind of gets to an interesting area. So, as these companies get into manufacturing, you start to realize that there's an awful lot that you need to do if you really want to take full advantage of these types of things, right? One is different design tools and different methods of doing design. So if you look at 3D printed stuff, a lot of times if you look at an example of like the kinds of things you can do, you can print structures that there's no other way to make them, right? They're lattice structures and they're very lightweight and have great properties. And if you go to a 3D CAD tool and try to like manually draw some lattices, and especially if you want the properties to vary across them, you'll quickly tear your hair out because they're not really made to do that. And so we need new kinds of tools. So it's both a challenge for these companies, but also an opportunity in that I think new tools will emerge for design. And secondarily, a lot of the promise of 3D printing in the future is going to be about mass customization. So I can tell you somebody like an Adidas would love for the shoes that they make to be fully customized to everybody, but you start to think about all of the rest of the ecosystem that needs to be present for that, whether it's the ability to scan your foot or the ability to kind of have a single design that moves all the way through production and gets shipped. And there's a whole bunch of, again, mostly software infrastructure that needs to get created to really make mass manufacturing that's customized be cost effective.
Great. So another one of those areas that has been around forever, but that seems to experience a revival in terms of startup activity, at least, is robotics. Why now? What's happening in robotics that suddenly it's sort of coming back to the fore?
Yeah, for sure. I think robotics is definitely one of these great examples of you can see many hype cycles in the past, lots of kind of unfulfilled promise, I guess. And I think there's a couple of things that have happened, and they're driving lots of different areas. But obviously, the cost of computation has continued to fall, and that's an important piece of it. But I think a really important part is kind of machine perception. So obviously, we're all familiar with all the stuff happening in image recognition, things like that. The technologies being applied there that are making big strides are also applicable to robotics, primarily on the perception side. So I think those are some of the kind of key things that are really driving this. And what that's allowing the industry to do is make robots that are both low cost because of the kind of lower cost of computation, but also safe to be around humans or able to be in kind of less structured environments. So there's tons of robots out there, but they tend to be in factories doing kind of identical tasks over and over again behind a cage. And the new generation of robots that's being enabled by the new technology advances can now kind of come out into an unstructured environment where the thing they're doing may be a repetitive task, but there's something about it that's changing every time. because maybe a human is doing the other part of the task or something like that.
I think one interesting example of this is abundant in agriculture picking. I mean, I read that now they're able to basically figure out what they're going to pick. So it's repetitive, but it's always different in that the size and maybe what is being picked is different each time. Is that correct?
Yeah, for sure. So abundant robotics is in apple picking. Sort of more broadly, they're in orchard agriculture, but the specific first product is picking apples. And this is this was an interesting area because if you think about how an orchard works, like there's a base amount of labor that's required all year to prune and do things like that. But around harvest, there's this massive peak that's required in terms of the number of people you need to get the things off the trees. And there's been an increasing problem with getting labor to do that. So in fact, apples stayed on the trees last fall in Washington, which is where most of them come from in the US because there wasn't enough labor. And so lots of people have looked at this problem in the past. The Apple industry's even sponsored research into how can we automate this. And it's been this huge issue for two reasons. One is the manipulation, taking the apples off the tree without damaging them and doing it at a rate that's fast enough to be cost effective has been very difficult. And then the other part is actually just kind of finding them, right? Like looking at the apples. It turns out when you go to harvest, you don't necessarily, especially if you're harvesting high quality apples for the supermarket, you don't necessarily harvest them all at once. You have to kind of grade exactly how ripe they are, and they don't all ripen exactly the same rate on the tree. And so humans are good at discerning kind of the levels of ripeness, or they can be trained to do that. And historically, robots weren't able to do that. So Abundant kind of made breakthroughs in two areas, and I see this in a lot of robotic companies now. One is on the manipulation side. They found a very unique and non-traditional method of doing the apple picking. They actually use a high-power non-contact vacuum. So they get close to the apple and they pull really hard with vacuum, and the apple comes off the tree, and they never actually touch it. And then they decelerate it through a clever method that doesn't induce damage. And then, as I was saying, things like machine perception have just come a long way, and that's the other enabling technology that enables them to kind of find the apples and pick out which ones are at the right level of ripeness.
What about the industrial world? So VO, for example, is one of your recent investments, and we'll have co-founder Clara at I think next month or the months afterwards. What was the thesis there?
Yeah, so if any of you are familiar with the robotics world, you've probably heard the term collaborative robotics, right? That's been the highest growth area in robots, which is this kind of stuff I was talking about earlier with robots that can be safe to be around people. And so, again, robots have been around a long time. Most of the robotic arms that are used are in industrial applications. They're very large. They're very high payload, meaning they can carry a lot. They're very fast and very precise. And they'll also kill you if you get anywhere near them because they don't know anything about you. So whenever you find them, they're usually caged in, and you have to kind of stop them entirely to get near them. And that's a problem for a bunch of different reasons. And so people would love robots to be able to be collaborative, and there's been this wave that emerged in the last few years. And if you look at them all, they kind of have a bunch of similar characteristics. They're usually pretty small. They're kind of more like the size of a human arm or a little bigger. They have relatively low payloads. And that combination of things allows you to build a robotic arm that's inherently safe. So, even if you get near it and it touches you, it hits you, it doesn't really hurt you. And that's, again, it's not moving very fast, and it's not carrying something really heavy. But if you go talk to all these people that use industrial robots, they love their robots. They would just love them to also be collaborative, and they can't use these new collaborative arms for many of the tasks that they're using robots for today because they don't have the precision and the payload. And so what Veo did was figure out a technology stack and solution that would allow them to make these big robotic arms safe to be around people. And that's really driven through, again, things like increases in computational horsepower, but also through new sensing systems. So they use things like 3D time of flight sensors, and they have several of them in combination so that they can make a safety critical system out of that. And so this now allows the robot to know what's happening in its environment and be able to kind of appropriately slow down and stop if something is going to be in its way.
Great. You mentioned the term hype cycle, maybe an industry that seems to be on the less favorable part of the hype cycle is drones, maybe. There's very hot maybe a year or two ago, maybe less so now,
sure.
or maybe you disagree. And you have some very interesting investments there: Airware, Zipline, Skycatch. Where are we? Is this industry about to happen? What's going on?
Yeah, so for sure, it started taking off several years ago in the hype cycle. This is one where I invested fairly early, and this was back when we did seed investments. So I placed several seed investments, again, Airware, Skycatch, and Zipline. So for those of you who don't know, Airware and Skycatch are both commercial drone companies. Today they're primarily in things like construction and mining. And then Zipline is in drone delivery. So they're delivering medical supplies in sub-Saharan Africa right now, and soon to be other countries, and then obviously eventually not just medical supplies. So yeah, I think we went through a big hype cycle, and I'll separate consumer and commercial. You'll notice from my portfolio, I didn't say this in the beginning, but I do almost no consumer investing. So just given my background was all kind of B2B type companies other than Zipcar, I naturally gravitate toward more commercial and industrial companies. So I'm going to leave aside consumer drones, but if you take a look at commercial drones, yeah, we went through this big hype cycle, and the reality was between regulatory issues not getting resolved as fast as people would have liked, and also, again, an ecosystem problem of many of the industries who could use these technologies need more than just an image coming off a drone or just a drone. They need real kind of actionable insights, which required a lot more to the solution than just a physical flying robot. So that kind of, I think, caused sales cycles to be long and took longer for folks to reach real revenue, and so I think that's why you've seen a slowdown. I am starting to see a bunch of companies that are going to look like this year, they're going to cross like the 20 million mark in revenue, and I think that's going to cause people to kind of start to pay attention again to the commercial drone space.
Interesting. Is that with one large customer type? I mean, not the whole 20 million, but are you seeing those companies having a bunch of customers across the space? Yeah,
several different companies I think will cross that milestone, and they're in different industries. So things like, most are diversified to some extent. So again, both Airware and Skycatch are diversified. They service like mining, construction, insurance, and then you see other people in things like infrastructure inspection. There's at least one company in that space I know of that I think will cross that revenue mark. So all of these are relatively diversified, customer-wise.
Great. And maybe one more of those spaces, and last but certainly not least, food, the reinvention of food. So you've invested in Soylent, you've invested in Impossible Foods.
Impossible Foods, Ripple. So Impossible Foods is ground beef without the cow, made out of vegetable proteins, and Ripple is a dairy alternative product. So today made out of yellow peas.
So. Milk without the milk.
Milk without the cow, yeah.
And Soylent, which is food without the food.
Yeah, that's right. Convenient vegetable-based food, yeah. So I've invested on both the food side and the ag side, and some that kind of cross over depending on how you think of Bowery, who I think spoke here previously, right? So they're indoor farming. On the ag side, I've focused almost entirely on what I would call digital ag, so essentially software being applied to farming to either increase yields or efficiencies. And then on the food side, this is kind of an unusual space for venture capital, right? Most food companies don't receive VC funding. Most are fairly brand-driven or commodity-driven, and there's not a lot of kind of technology to them. And so when we looked at the space, I thought it was a very interesting space just because of its sheer size and kind of ability to make an impact. But the question was, is there a place for venture capital inside of this? And are there trends that a VC can invest into? And so I did a bunch of surveying, and one of the things that started popping out was, there is a consumer trend toward, I guess, away from animal agriculture and looking for kind of cleaner sources of protein. So vegetable proteins, things like that. And it turns out, the big CPG companies and stuff, they just, R&D for them, again, is creating a new brand or actually just not even doing that. They just go out and buy one that's looking successful and make it bigger. And there was this kind of wave of companies that is still existing that has started trying to apply real technology, life sciences type technologies and chemistry and things like that to food to try to make demonstrably better products that are also protectable, meaning there is a technology behind it. And so if you take a look at something like Ripple, they're making a non-dairy milk, and of course there's soy milk and all kinds of things like that have been around for a long time, and it's growing. That industry is growing very quickly. So it's like 4 billion or so now in the U.S. and 15% CAGR. So interesting for startups. And what Ripple said was, hey, all these products that are out there are generally lacking in some dimension. So you take a look at almond milk or rice milk, and they actually have almost no protein. But the whole reason we historically drank milk is for its protein content. And so they said, why don't they? And it was like, well, the ingredients that allow high protein don't taste well or don't homogenize well. And so they came up with a way of purifying vegetable proteins that was very scalable and low cost that allows them to then create products that are demonstrably better than other things in the market. And importantly for a VC, you can't just copy, right? Like there is actually protectable technology there. And so you can build a technology-based company in these spaces now.
Great. And taking a step back, so there's not many investors like you. So, you invest in what people tend to think of as frontier tech. Is it in part because it's your background professionally and as a startup, professional and founder, or do you think there's something fundamental that's happening across all those areas right now?
Yeah, I mean, I think it's a combination of things. First of all, obviously, given my background, having crawled around things like semiconductor factories and dealt with like long supply chains and stuff, like I guess I both have a healthy appreciation for how difficult that stuff is, but also I'm kind of not afraid of it, right? I know it can be done right. You can build real companies there. Venture is a very competitive business. There's a lot of money out there. So when you enter it, you look for a place that you believe you can add value and that's differentiatable. And for me, that was the areas I invest in because I have a background in them. I also have a family background in ag, which is why that one's of interest. And yeah, I think there's also a bunch of trends, some of which were talked about earlier, that the cost of prototyping hardware has been coming down, right? There has been a lot of effort put into, making the iteration cycle on hardware faster. And some of that is things like 3D printing, right? Where before you would have had to wait forever to get a prototype part, now you can print one on your desk, right? So, and that kind of thing I think is enabling a lot of the hardware technologies we look at today to be more amenable to the venture model. The other thing I like to point out is that if you go back not that long ago, almost all venture was funding hardware. So whenever people tell me that like hardware is this new thing, I always kind of laugh and ask them if they know why Silicon Valley is called Silicon Valley.
And what are you looking for, right? The age-old question, but this space is a little different, right? Because a lot of it involves deep tech and research and IP, and by the time a company shows up at Series A level or Series B level, compared to their, say, SaaS cousins, they're going to look very different, right? So how do you evaluate an opportunity?
Yeah, so particularly at the Series A, obviously if you're SaaS, a Series A, you're looking for a particular MRR or something, right? And like usually when a company in these spaces is raising a Series A, there's not actually a product shipping yet, and there's still a lot of money to go, right, to get it there. So I think this is super cliched, but the first thing we always look for is team in this space. Like one of the lessons I've learned is that particularly like a previous founder or somebody with like a ton of industry expertise in some particular industry can catch the attention of investors and have an unfair advantage in raising money. And when you're in a space that does require more capital than normal, you need to have those kind of unfair advantages. And so I often look to back teams that have those. And again, it doesn't mean that they're always a repeat founder, but maybe they have deep expertise, whether it's like professors who are well known in the industry or things like that on the team. That will help kind of get other investors there as well in the future. Also look for people who, I guess, understand the difficulties of this space, right? Like that it's not a team of people who have only built 3 mobile apps and then they've decided they're going to do a hardware company. It's people who have actually been involved in the space somehow. And again, it doesn't need to be the CEO, but they've got to have that DNA on the team. I've learned in many of my investments, supply chain is critically important, right? A lot of the things I've invested in have very deep and very wide supply chains. Whether it's something like Ripple in the food space or Impossible Foods, or one of my consumer investments, the very few that I have is Light, which is a computational camera. And you take a look at the number of parts that are in that thing, it's truly staggering, right? And everything from optics to electronics, they have an ASIC in there, they've made silicon. I think I always look for, do you understand that supply chain and do you have a way to kind of wrap your head around it, which is always tough for a startup.
And maybe to close, and at least from me, and then I'll open up for questions. Any lessons learned into, what works, what doesn't work, how you get those first customers? Do you want to go for, one segment, two segments? How do you experiment? Any lessons learned that comes to mind, specifically for those companies?
Yeah, so many. I think the speed of iteration, which was mentioned earlier, I think is a really important one, because I think at the end of the day, you really do need to pick one target market to start with, and kind of really knock that one down and go from there. And so, because you're not always going to get that first one right, you do have to have the ability to kind of iterate quickly on your product. In terms of getting those first customers, it really vastly varies by the industry segment you're in. But it's another actually thing I should say is we do often look for people who have some unfair advantage in that particular aspect, whether it's they came out of the industry or somehow have a Rolodex or something that gives them access, or they've figured out a channel into a market that's unusual, so they have unfair channel access, things like that.
Great, thank you very much. All right, let me open up to you guys. We have a microphone here.
Thanks for those comments. Could you talk a little more about augmented reality, virtual reality? It's kind of at the intersection of consumer and hardware, and where you see those applications and how GV is exploring in that space.
Yeah, for sure. So first I'll say there's another partner at GV who spent a lot more time in that space than I have. He was interested in it really early on, and while I've worked with him on a little bit of it, I would say it's not my space. But overall, we have a small handful of investments in that sector in a few different categories, like in content creation, for example, things like actual camera technology, and people running studios for the content. If I look out at it, I think for me, augmented reality resonates a bit more, given, again, my kind of less consumer bent. I see a lot of applications on factory floors and things like that. We had one seed investment that's in that space. And so that when I look at it, that's where I see kind of excitement going forward. And I can't really, again, speak to the consumer side. So,
hi, you've seen a lot of startups come and go, and my question was, if you are, there's a lot of these startups, deep tech startups, start with coming out of PhD or something like that. But if you're starting from the problems, business problem side of things, and then you're developing technology, what would you say is the best way forward when it comes to fundraising and where the money is coming from? Because a lot of what I've been told, it comes from like government grants and whatnot. Especially, I come from Europe, so there's a lot of Horizon 2020 kind of grants. But I'd love to get your perspective on what you see succeed most.
Sorry, just to make sure I understood the question. What I see succeed most when the founders are not coming out of, say, PhDs and technology backgrounds and are more coming out of industry, or
yeah, they see a problem that needs to be solved, and there's enough demand, but now they're going to start developing the technology for it, and they have some ideas of how to, but not. They need money for developing it.
Yeah, I mean, I think most VCs will tell you that that's the right way to start, right? If you start just with the technology, and try to find a match for it on the problem side, that's not usually the way to the most successful companies. So, I would say, like, again, most of the successful companies start the side you said, and if it's the kind of thing where you do need a deep technology background in order to actually build it, what I've seen the best leaders do is go and find those people out of academia or out of other technical backgrounds. Like, if you take a look at Desktop Metal, it was started by the CEO, Rick Fulop, and he's not a metallurgist or a mechanical engineer, or actually he might be a mechanical engineer, I should make sure. But he went and recruited a bunch of professors out of MIT, including somebody who had invented binder jetting as a technology, which is what they use in their production technique, and he recruited metallurgists, one of the fathers of metal injection molding, which is, again, some of the core technologies for what they did. And so, if you go get a team like that, and you've got a well-defined problem that came from the founder, you should have no problem raising money.
Grants.
Got it. I will say that it's rare that the biggest companies that we see in terms of like us as a firm started with grants as a company. But there might have been grants in a university setting, but usually, grant funding doesn't kind of give you necessarily the same sense of urgency, or a company the same sense of urgency that raising equity financing from a professional investor does. And so usually I see that the teams that go the fastest and kind of have the most urgency to get a product into market and get product market fit have more traditional equity backing rather than grant financing. Because the grants can sometimes take you astray, right? What I've seen is that, you figure out what the government is willing to give you, or what the grant writer is willing to give you, and you kind of tailor it to that, right? And sometimes that is or isn't what the market is looking for, right? It's just whatever they happen to be giving grant money for. So.
Hey, Andy, thank you for your thoughts on all that. I'm curious, since you invest across so many different industries, how you stay up to date on current trends, and then sort of develop a deep enough understanding of either an industry or a company in order to make an investment. Kind of what your thought process and your strategy is of going about that.
Yeah, I would say two things. One is I try to read a lot, and the other is I try to talk to a lot of people. So if you dive into a particular segment and start meeting and talking to both entrepreneurs and experts in that space, you'll start to see trends emerge by just talking to enough people. And where it's possible, I try to read background material on the space too.
Andy,
Yeah.
You talked about serial entrepreneurs as one really good trend. Not that you only back them, but that's a strong sign to build these more challenging businesses. I was curious if, as you look at all the founders you've backed, do you see a lot of people that somehow managed to start a deep tech company before and they're doing it again, or people that started much simpler businesses? Famous example I guess would be Elon Musk, that started some software businesses that were a lot less complicated before the ones he's done now. I don't know, do you have any sense of which of those two kinds of patterns you see more often?
That's a good question. I mean, I've seen both work, but if you've built only software companies in the past and then you try to jump straight into something much harder technology that involves building physical products, it's a tough transition, right? I've seen people do it successfully, just surround themselves with good people and they're great leaders kind of regardless of the space, but I've also sort of seen it be just too much for somebody to wrap their head around in terms of it's so many different domains and disciplines that you weren't used to having in your organization.
I'm just wondering how, as you look at a new product, you look at how it transforms the environment it's going to work in. I spent a summer in an apple orchard, and half the trees in an apple orchard are not profitable. They're there to keep the workers employed between the two varieties that are profitable, that come into ripeness 3 weeks apart. And you can imagine if you could replace the staff with robotics, you can get rid of all those unprofitable species or varieties that you don't need because you're not having to employ people for 6 weeks. So as you look at new technologies, how do you see things like this?
That's a good question. I would say that comes largely from talking to people in the potential customer set and trying to understand a lot more about the industry. And sometimes the kinds of things like you're talking about, that just doesn't come until you're already in the market and seeing the kind of effects of the technology, right?
Okay, I think we actually, what? Okay, I think that's all the time we have. Thank you very much. We appreciate it. Thanks for having me.